Here's what we're going to do today. Today's kind of a big day, actually. And then if you remember, on Thursday, we're going to have a take-home quiz. Remember?
Yeah, take-home quiz.
Yeah, so it's kind of like, well, it's going to cover all the stuff we've done in Chapter 7 and this. Yeah.
We're going to have a take-home quiz.
That's right.
No, on Tuesday. I mean
Thursday. Today's Tuesday.
Thursday we're going to get a take-home quiz?
Yep.
Alright.
Yeah, it's going to be over all of this. Now, today what we're going to do is we're going to have like some quadratic equation, like, I don't know, x squared minus, let's say, 4x minus 45, and we're going to graph it, right? And Ivan, do you remember what a graph is?
Mm-hmm.
Yeah?
I know what it is. You want me to tell my definition of graph?
Yeah. What's your definition of a graph? Let's see what you got. So,
graphic.
Yeah, graph.
That's all
That's also
a graph. Okay, I see.
Is a giraffe? No. Well, like, I guess you could say a graph is
something about all answers.
It's a picture.
I guess
Picture of all answers.
Yeah, it's a picture of all the answers. Yeah.
I
Like,
would say like an area, like a
with all the answers in
of
it,
all the answers.
like all the possible answers in the graphic. All
so
the possible
it's a
and
picture of all the answers, right? And for these kind right here, the answers are ordered pairs. It's going to be like a number for x and a number for y, right? Okay, so there's patterns. There's patterns that we can use here that's going to make our life easy. Because you see that this is called a quadratic, right? The exponent is 2. So these, they always make a parabola, which is either going to go up like this, or it's going to go down like that. It's one of those two. Okay? It's one of those two shapes. Now, how wide apart this is or how skinny it is, those are all depend. But here's the thing I want you to see. They will, like our coordinate plane could be something like this. Do you see? And if it was like that in blue right there, you see you would have 2 x-intercepts, right? However, instead of the x-axis being right here, it could be instead, we'll do it in orange, it could be down here. And in this case, you'd have no x-intercepts. Or, one other possibility. It could barely touch at the very bottom, and then that would be 1 x-intercept. So for the x-intercepts, we're either going to have 0, 2, or 1. And we actually already know how to find them. You can either factor to find them, or you can complete the square, or you could use the quadratic formula.
The factoring it will be easy.
Yeah, if you can factor, like this one you can factor, then that's what you should do. Like this one, if you're factoring it, like it's going to be y equals x minus 9 and x plus 5, right?
Yeah.
Okay, now the thing is, I don't know if you guys remember this, but for x-intercepts, y always equals 0. So what you're going to do is you're going to put a 0 for the y, and you're going to solve it. So you see x will be 9, and x will be negative 5. So this has 2 x-intercepts. Does that make sense? 2 x-intercepts. So let's see here. You're either going to have 2, 1, or 0. Okay?
And for the y-intercept, x equals 0.
It does. We'll get that in like 1 second. I want to make sure.
Alright.
I want to make sure we got this right. So what we're going to do is we're going to graph quadratic equations. And quadratic equations have a degree of 2. The biggest exponent is 2. And they're going to have a shape that's called a parabola. It's either going to go up like this, or it's going to go down like this. Right? And x-intercepts. There's either going to be 0 x-intercepts, 1 x-intercept, or 2. And the way we find the x-intercepts is we set y equal to 0, and then we solve the equation. Alexa, is that good?
No.
No? What's your question?
That problem you did.
Yeah?
Why? Oh, or is that 0?
0.
0 equals x.
Yeah, because like for the x-intercepts, y always equals 0. So we put 0 for y.
Oh, for the x-intercept?
Yeah, y is
always
0.
equals 0?
Yeah, y equals 0 for all x-intercepts. Now what Ivan was saying, and he's right, for a y-intercept, x will be 0. And for the y-intercept, there's always 1. For these kinds of graphs, there's always one y-intercept. Always and forever, amen. And the reason that is why these sides, they go up, they also go out farther and farther and farther. So no matter how far away the parabola is from the y-axis, because it's always getting wider, it's eventually going to cross the y-axis.
What about if they're sideways? Would that be 0 y-intercept?
So there are sideways parabolas, but they don't come from these kinds of equations.
Oh, okay.
Yeah.
Are those two x's, x equals 9 and x equals -5?
Yeah.
Why? Why two x's?
Because you have two x's right here.
But
So
one is -9 and one is +5. Why?
No, it's x minus 9
Oh, x minus 9
times x plus 5. So we have to solve that. So either x is equal to 9, because 9 minus 9 is 0, right? Or x is equal to -5, because -5 plus 5. Remember? You forgot. Oh my gosh, Alexa, you're killing me. Oh, that's okay. But yeah, that's fine. Remember, you factor, you take each factor, you set it equal to 0, and you solve it. I know, it was a while ago, but yeah. Okay. So, these next two parts you don't know yet. Well, you might, but we haven't learned them. So these next two parts are new. So today's actually a lot, now that I think about it, Mr. Flowers, because we gotta see how these work, even though we've kind of done them. We gotta see how they work. We gotta see how it fits together with these two, and we have to draw the graph. Man, Ivan. Oh, you ready?
So we're solving quadratic equations.
We're graphing them. We're gonna graph them. Yeah. Now the vertex.
Desapareció todos los highlighters.
So the vertex is where the parabola turns around. Now the parabola, again, that's the shape, right? So the parabola is the shape that the quadratic equation makes, right? So it's that curvy thing like this or like this. And the vertex is where it turns around. So like, I'm just going to draw some generic one. So here's my generic parabola, right? This point right here is called the vertex. That right there is called the vertex. Do you see? It's going to be either the lowest point, right, or it's going to be the highest point. Now there's something interesting about the vertex. It's actually not part of our graph, but we can use it to help us make a graph. There's this thing called a line of symmetry. Now this is a hand-drawn graph, so it's not exactly right. But there's a line of symmetry that goes vertically right through the vertex, and then each side should be like a mirror of the other side. This one's not drawn right, because like you see, this one's going.
It's not symmetric.
Yeah, this is going up too fast. I guess if we're going to try to draw it more carefully, this would be better. Okay, there we go. Now it looks like a line of symmetry. Okay, so this line of symmetry right here, Mr. Flowers, is going to make our life easy. You'll see why in a second. Okay, we'll talk about the range in a moment. We'll save that one for the end. Okay. So the only thing you don't know that we're going to find out to graph our first one is how to find the vertex, but we'll do that right now. Okay. Ivan, check this out, buddy. Let's say I was going to graph one like let's say I was going to graph this, right? You guys can see that? Y equals -2x minus what? Y equals x squared minus 2x minus 24? Yeah? Edgar, word to the wise. Make a list of the stuff you got to figure out. And here's what we got to figure out. You have to figure out your x-intercepts. There's either 0, 1, or 2, right? And for your x-intercepts, y is 0, so you put a 0 for the y. You also need to figure out your y-intercept. You got to figure out your vertex, and then we'll do the range in just a minute. So Alexa, this kind of helps us keep track of what we're doing, right?
Yeah, but
So-
why? Yeah, oh, right, I forget.
Oh, okay. I forgot it already. So, Ivan, you good with this? We're going to fill out this chart. It's a whole bunch of work. It is. It's a lot of work. And then it's easy to lose stuff. That's why we keep it all right here. So let's do the x-intercepts first, okay? So we want to check to see if it's factorable. So we set it equal to 0. If it's factorable, life is good. This one is factorable because, well, a is 1 and there are a pair of numbers that multiply to 24 and add to -2. That would be x minus 6 and x minus 4. Is that right? So x equals 6 and x equals -4. So -4 and 6. So that's my x-intercepts.
So does it matter if you put 6 and then -4 on the bottom?
No.
Okay.
Either way. We good?
But I missed why is there 2 x's?
Because there's 2 x-intercepts. Because there's 2 solutions. Because it's factorable. There's 2 factors that multiply together to make 0. Yep. Okay. Ivan, now the y-intercept is the easiest one when it's like this. Not all quadratics look like this, okay? So you got to be careful. Because sometimes they look different. But when they look like this is, then you put a 0 for x, right? So watch what happens. Do you see your y-intercept is just that number right there? But that's only when it's written like this. There's another way we write quadratics and they don't look like that, and you can't use that same shortcut.
When can you not use the same shortcut?
When it's not written like ax squared plus bx plus c. There'll be a different way it's written. You'll see. But for today, we can do that. All right. Now, you know how, well, this was the y-intercept, right? Okay, now let me tell you about the vertex. You know how we have y equals ax squared plus bx plus c, like we used for for the quadratic formula? You know what I'm talking about? So for this one, a would be 1, b would be -2, and c would be -24. Yeah? Yeah? Yeah?
Why 1?
Because there's 1x. There's not a number there, so it's just 1.
Oh.
Because 1, like you don't need to write times 1.
And why negative? Oh,
-2, -24. A, B, C. Right? Remember? Okay, now, there's a formula for the vertex. And it's going to look really ugly.
I'm sorry, where did you get a equals 1 and b equals -2?
Right here. A, B, and C. A, B, and C.
Jesus Christ.
Oh, yeah.
This is giving KK. Alright. I get it.
Okay.
See, please.
All right.
Wait a second. No, I'm just-
Wait a minute. Where did I get 1 for A? Hey, oh my gosh. Edgar, wait, Edgar.
Yeah.
What? Why is A1?
Why is what?
A1.
Yeah.
Where'd I get that?
Well, A is 1.
Okay. I'm just
X
teasing.
1, yeah.
Because she asked, and then as soon as I get done answering her question, he asked the same thing. It's okay. It's
Sorry, I was in
fine.
my-
No, it's good. It's
my
good.
own world.
I know, it's okay. Okay. So, are we all on board? Because I'm going to show you a formula, and the formula looks really ugly, but it's easy.
Negative.
Okay?
Right. Vertex.
Yeah. So the thing about the formula is the formula gives you a coordinate. it's going to give you an x and a y. Okay? It's going to give you a coordinate. It's going to give you the x and a y. So the x is negative b over 2a. Right. And then, man, this might not make sense to you guys, because now that I think about it, I don't know if we've done, I'm getting confused. I don't know if we've done function notation for this class. I don't think we have.
No,
Probably
this
we
is
have.
hard. I don't.
No, it's not hard. It's just a confusing looking. No, you cálmate. Look, just just because it's confusing looking doesn't mean it's difficult. I'll show you. You don't trust me?
No.
Okay, we'll just make it hard then.
No.
All right, check it out, Alexa. Look, this is, so you know what A and B are. A is 1 and B is negative 2, right?
Maybe I don't know.
Yeah, well, okay. I hope you do. Okay, so A is 1 and B is negative 2. So what you're going to do is you're going to take those numbers and plug it in right here. And this will be your x coordinate. Okay? So negative, let's see, 1,
negative 2.
2 times negative 2, right? So that's negative 1 over negative 4. You have to simplify that. That's positive 1/4.
I think you made a mistake.
Why?
Because isn't it?
I hate my life.
Why am I always doing this on him too?
No.
Well, you know why I wrote it? Because that's what he said.
To test.
You see, Alexa?
Yeah, no, he
It's
said
all for you.
I wrote what he said,
was a test.
and he was saying it when I was writing it, and I just wrote what he said.
Austin?
It's not his fault. I mean, I should have not have written it. I should have been,
Yeah, you should have.
but I was just listening and I wrote it. That's okay, no big deal.
So that's gonna be.
I'm glad you caught it.
Yeah.
Negative b. So
That's gonna be.
negative, negative 2. And he wasn't saying, just to make sure, he wasn't saying it wrong. But I started writing, and he was talking about this part, and I was already writing that part. And so then I just, I messed it up. It's my fault entirely. So 2 times 1.
It's funny how that works.
Yeah, it is, right? So a negative times a negative is positive, so that's 2 over 2. That's positive 1. Oh my gosh, I'm glad we caught that before we got too far.
Mío.
I know.
Except for the win.
Favorites.
Okay, now, Alexa, here's all this means right here, okay? All this ugly thing right here means you take your original equation, right? And everywhere you see an x, you put your answer that you just found. That's all that means.
Everywhere you see an F.
An x.
Oh.
So you see our equation is x squared minus 2x minus 24, right? So what we're going to do is we're going to take our answer and plug it in. So it's going to be 1 squared minus 2 times 1.
That's the answer of the vertex 1?
This is the x coordinate of the vertex.
Your what?
The x coordinate. You know, it's an x and a y for a coordinate, right? That's the x part.
Of the vertex.
Uh-huh. So to find the y part, we take, to find the y part, we take that number and plug it in.
Oh, and the answer.
Yeah, because you know, it's going to be on a coordinate plane, and I don't know where 1 goes. Like, 1's just a number, but I need 2 numbers. Okay, so I go to put a 1 in. I'm going to try not to mess this one up. So 1 minus 2 is negative 1. I think that's negative 25. Don't trust me, because I apparently can't do math today.
Mr. Brain.
Jimmy.
Mr. Has anyone ever called you Mr. Cafe?
Oh, yeah.
Mr. Bell.
Oh, yeah.
You can't see that.
And Moreno.
Moreno.
Mhm. And lots of other things, too.
They do tell you in high school?
What?
Like,
Mr. Cafe.
Like that?
Call you?
Or bad names?
Señor Cafe.
Yeah.
Profesor Cafe.
Yeah.
I mean, some do, but they're like, they have a problem. It's not even me. Not even them. Like, they don't even bother me. Nobody messes with me. Yeah.
So after we find, after we plug in for the vertex
Yeah.
formula,
Yeah.
the answer we plug into the original equation
Right.
to find the other point.
To find the y.
So,
Yeah. So that's what that means. This just means take your answer here and plug it in for x. Yeah, that's all that means. So that's ugly formula. So, yeah.
when does this class end? The 4th?
I don't
4th
know.
of December, 3 weeks before Christmas.
I don't remember.
You don't remember?
We have it written
So
down.
we still have like.
But focus. Hey, wait, come on, focus.
Oh,
Focus.
sure.
This is a big idea. Listen, focus. Shh. Focus.
Don't know what to see.
Focus. There's like a bunch of stuff we got to put together at once. Alexa, we'll figure it out in a little bit. Focus. So listen, we need to put all this on the graph. And this is the part where it gets a little bit tricky because you have to be able to draw the graph too. So what I'm going to do is I'm going to draw a coordinate plane right here.
Well, where did you get negative 25 from?
Because you take that number and you plug it in. Remember, you take your answer from this, which was 1, and then you take your original equation, and everywhere you see an x, you put 1, and then you just do the math.
1 and 1, 1 minus.
So it's so this is our equation: x squared minus 2x minus 24. So you plug 1 in, and then see what you get, and you get negative 25. Yeah. Okay, so these are the points we have. We have 1, 2, 3, 4 points. Sometimes we won't have 4 points. Sometimes we'll have 3. Sometimes we'll only have 2 total. All right, so here's what we got. We got negative 4 and 6. Now, do you see how I'm not putting numbers on my graph yet? And actually, graph paper makes this really tricky. Because look, you don't want to have to go all the way down to negative 25 on graph paper. That's a whole page, and then it's going to be kind of ugly because you're going to have to hit negative 4 and 6. So here's what I would do. See that point right there? That's 6, 0. That's a good joke. That's 6, 0. And then if that's 6, then 4 is a little closer, so that's negative 4, 0. You see how I did that? So those are my x-intercepts. And I know those are the x-intercepts because I found them over here. Now the y-intercept's negative 24, which is going to be, negative 24 is going to be like, right there. Negative 24. Okay? X-intercepts, y-intercept, the vertex, remember the vertex was 1 and negative 25. 1, negative 25. That's my vertex. Okay? And there's a lot of information here. So, before I draw my picture, here's another thing I want to tell you about. Do you see how, for our equation right here, do you see how A is positive?
It's going to go up.
Yeah, so if A is positive, it's going to be a parabola that goes up. But if A was negative, it's going to be a parabola that goes down. So that kind of gives you a clue how to draw it, right? Now, this one's pretty easy, but I'm going to go ahead and draw my line of symmetry. But, Edgar, be careful.
I always suck at doing lines.
Edgar, be careful, because the line of symmetry, it's not part of the graph. It just helps you draw it. Because the right side and the left side of this should look the same. Edgar, do you understand what I'm saying? They should look the same on each side.
Oh, yeah.
Now because they're going to look the same, you see this point? You see how far away it is? There's going to be like a point of reflection right there. And that can help me find it. That can help me draw my graph because, you see? That's how the line of symmetry helps you. Now, it's not a V. And it's not a U. It's like a U and a V had a baby. Kind of like that. Well, you know how a U at the bottom is curved? So it's like that. But a V at the top goes farther and farther away. It's kind of like that. It's not straight. They're curved forever, but they get farther and farther away. Whereas a V, as like a U, the sides over here are like usually parallel, and it's not like that. So they're going to get farther and farther away, but they're curved at the bottom. So we have to try to draw that shape. So it goes through here. Now this is the vertex. That's the bottom point, right? So, man. Ay. That's really ugly, but that's what I got for right now.
So it's a VU.
Yeah, it's called a parabola.
The curve of the U,
The bottom of the U, but
the bottom of the V and the.
no, not the bottom of the V. The V is a point. No.
That's the V, mister?
No, a V has a sharp point at the bottom. This does not have a sharp point.
Sharp.
No, it is curved. It goes through those points. It's very narrow, but it's curved. Not straight lines. If you're drawing straight lines anywhere on a parabola, it's wrong.
So
Curve.
if A is positive,
Yeah.
then what?
Then it's going to go up like this. This is going up. That's what we call it. if A was negative, it would go down like watch, Alexa. If A was negative, it would look like this. Ooh. Okay, so we doing good? So far, so good. Okay, so let's back up. Let's make sure we got this because this is tricky. It's complicated. A lot of stuff. So Edgar, mira. To make a graph of this, what we're doing is we're drawing a picture of all the answers, right? The way that we're going to do that is we're going to find the x-intercepts, which you set y equal to 0. We're going to find the y-intercept, which you set x equal to 0. Then we're going to find the vertex. We're going to use this formula. Negative b over 2a. You get that answer, and then you plug that answer into x to find out what y is. So you get all those points, right? Take all those points, put them on the graph, draw your line of symmetry, draw your graph. It's a lot of chances to mess up. And there's one thing we haven't even done yet. Range.
What?
Range. Range is all of the possible y values. So we'll write that right here, watch. Range is all possible outputs.
Going it back to the range.
Negative 25 and infinity, I guess.
You're right. The vertex has a lot to do with the range. So what you're going to do is to answer for the range, you're going to look at the vertex. Because that's either the smallest number or it's the biggest number. Yeah. So the range is from negative 25 to positive infinity. We're just going to write our answer just like that for right now.
So it can be negative 25 to negative infinity?
No, because that would be... I'm glad you asked that. I'll draw you a picture of what that would look like. Okay? Because you're asking what if it was negative 25 to negative infinity, right? That would be this in red.
So it can be
It could be.
But an answer can be like
That's if it's
5
negative
to
though.
So
negative
in red right here, it would be negative infinity to negative 25. That's in red. But our graph is not this. Our graph is from negative 25, right, to positive infinity. Because it's going up.
So the answer
Ivan, you got questions so far?
Nope.
Not yet.
Not yet, mister.
Okay.
But it's barely 7:14, so let's get to see what happened.
All right. Now look, Edgar. If you got your head around this, you gotta stop texting me though. It's creepy. I blocked your number. Okay, Edgar. Though, look seriously. If you've got your head around this, they're all the same.
Yeah.
Like it doesn't matter if it's factorable or not factorable, if it's imaginary. So should we do it?
Infinity is just like
Going up.
yeah, going up.
Going up, yeah.
Going up.
So let's do a tricky one together, right? Like let's do one that's about as like IK fail, like super ugly. Ready? And we'll do it together. You ready? Do you have a question, Alexa? Do you have a question? Okay, Alexa, here we go.
Negative b over 2a. F of negative.
I know.
I see. Listo?
The result right there, you know?
This is the y. Yeah.
Oh no. 14.
Graph.
Ladies and gentlemen.
Oh, has a number now? Wait, that means it's gonna be super skinny, right?
Yeah. So you're right. Like if there's a leading coefficient, if it's a whole number, it gets skinny. If it's a fraction, it gets wider. Yeah, we'll talk about all those shortcuts eventually too. But for now, we're gonna graph them. Okay. we make our list, right? First thing first, make your list. X, Y, vertex. Oh, actually, here.